When I was small, I heard that using refrigerators caused global warming and melted the homes of polar bears in the Arctic. Back then, I thought that we somehow transported ice from the Arctic across the world and used it to keep our ice cream fresh and cold. Obviously, that's not how a refrigerator works. A refrigerator cools down its contents by taking the heat inside and moving it outside. But how does it do this? Let's take a look inside a refrigerator. A loop runs throughout the system. Inside this tube, a special fluid called a refrigerant flows that boils at a low temperature. Here, a cycle called the refrigeration cycle takes place. First stage, evaporation. Hot air flows near the tube. Heat is transferred from the air to the cold refrigerant, causing the refrigerant to boil and turn to gas. This gas flows along the tube to the compressor. Second stage, compression. Along the way, the refrigerant gas is compressed to high pressure, causing its temperature to increase. How does this happen, you ask? The gas particles inside the compressor are moving. As the walls move closer, the particles hit them and bounce back at a higher speed. This higher speed causes the kinetic energy and therefore the temperature of the gas to increase. Still confused? Imagine hitting a tennis ball with a stationary racket. Now imagine hitting the same ball with a moving racket. The ball will bounce back faster in the second scenario, right? This is because the change in momentum of the ball is greater. Now, what was the purpose of this compression? Why did we have to increase the gas's temperature? You'll see in the next stage. Third stage, condensation. Heat will always move from a higher to lower temperature. To ensure the refrigerant temperature is higher than the surrounding kitchen air, compression was needed to raise the refrigerant's temperature. So, heat energy is transferred from the refrigerant to the surrounding kitchen air. The refrigerant condenses back to liquid. Lastly, expansion. The pressure of the refrigerant is lowered, causing its temperature to decrease back to in the first stage. This process repeats again and again and again, preserving your ice cream for a sunny day. Yum! Think about it next time you enjoy your favorite ice cream.